All right. I think we will just get started and more people can jump in. So welcome to another session of Ask Mayfield Anything. I'm Kristy Drutman. I am the Content Marketing Coordinator at Mayfield Renewables. Today, we are going to be having a really exciting discussion about unlocking ROI on Solar+Storage. Like I said, I'm Kristy, and I'm really excited to be moderating today's conversation. So I'll be fielding your questions and answers. So make sure that any questions that you have during today's session, you put it in the Q&A box. And I am joined by our founder and CEO, Ryan Mayfield. And I want to give you a quick brief about Ryan and his background in the industry. So Ryan has been working in the renewable energy field since 1999 and founded Mayfield Renewables in 2007. His career has blended technical expertise with an affinity for writing and education. Ryan holds a degree in environmental resources engineering and has a limited renewable energy technician license in Oregon. And next, I want to introduce our special guest. Actually, we have two special guests. First is Quinn Laudenslager. I hope I didn't butcher your last name, Quinn. You can correct me later on. Okay, awesome. Quinn is the Senior Manager of Technology and Product Operations at Energy Toolbase. Quinn has worked in the renewable energy industry for over 15 years, starting as an electrician and working in many different roles from operations, development, to leading teams responsible for solar and solar-plus-storage development and construction. He brings over a decade of commercial and residential solar-plus-storage experience, covering everything from hands-on construction to high-level executive management. Quinn now works as a senior product manager at Energy Toolbase, dedicated to ensuring that Energy Toolbase controls and delivers exceptional results for all deployed assets and continuously explores new possibilities to leverage their technology. Thank you so much for joining us, Quinn. And from our team, we have Justine Sanchez, who is the Solar+Storage Program Director. Justine has worked in the solar industry for the past 26 years. She brings a wealth of experience in PV and energy storage system design, education, and industry leadership to our team. Justine joined Mayfield in January of 2020 and currently spends her time developing and teaching workshops on energy storage systems, reviewing electrical plan sets for PV and solar-plus-storage projects. And she also acts as a project consultant and facilitator for commercial scale solar-plus-storage systems. We'll be talking more about Justine's work on our energy storage workshop series later in today's discussion. So now we will get started with why you all are here, which is to talk about unlocking your ROI on your solar-plus-storage system. So we are going to have Ryan kick us off by talking about why we're even discussing this in the first place, and we'll let the conversation flow from there. So go ahead, Ryan.
Thanks, Kristy. Really appreciate it. And thanks everybody for joining. This is great. We've been talking about this topic internally, and then as we were talking with Energy Toolbase, this is proving to be a very robust topic and just a lot to think about. And so hopefully the conversation here will be illuminating for everybody. We had some great conversations in preparing for this. So, a big part of what we're trying to get at here is, looking at the modeling and the management, which Energy Toolbase has some expertise in, and we'll be able to shed some light on that. But being able to look at energy plus storage systems, what kind of return on investment can you get, and how do you calculate those? And so that's those are really the big things that we're wanting to talk about. And so, I'm just going to kind of bring Quinn and Justine into this conversation. One of the things that I should say it this way, in our prepping conversations, this was great, this kind of came up. It seems like, and Quinn, I think you get this a lot, and Justine, I know you do, because we're talking about it all the time. There seems like not that there's only two ways of calculating return on investment, or two lenses to look this through, I should say. One is on the resiliency side. We get that a lot, and us personally at Mayfield, we we're doing a lot of work around the resiliency stuff, so we get that a lot. So that's one aspect, but then there's these demand charges, and I know that that's something that in a lot of markets, as you can see on this map on the right, the higher the demand charges, the more likely is that you have some good return on your investment with putting in storage. And so I think one of the ways I would love to kind of kick this off and start talking about it is, in the lens, with that resiliency lens, how are you seeing people value and calculate that return? So Quinn, I think maybe I'll ask you kind of that question first. If your customers are coming in talking to you about that, how are they doing that? How are they valuing the resiliency aspect, and be able to put a dollar figure on that is what it comes down to.
Yeah, no, I think this is a great topic that comes up repeatedly. And I'm just going to say that there's not a single way that everybody is unilaterally looking at the value of resiliency or just being able to put an ROI on a resilient asset. So of course, where everybody sort of first focuses on is exactly that chart that's on the right-hand side there, where they say, okay, what can I get from a bill saving standpoint for my energy storage system? But the first real question that you have to answer there is my energy storage system capable of doing both operations? Can it save both money on my electric bill and actually provide me resiliency and backup power? Also, when you start digging into those, I guess, different arenas. So, okay, bill savings is pretty straightforward. You lower your demand charges by reducing your total demand at the facility. We'll get into how bills work a little bit later, but ultimately the other aspect of the resiliency is, well, what does that mean to me for my facility? Which again, there's not one unique or, one unilateral facility. Each one is unique in how it operates. But some of the things that we see that help kind of guide that conversation is, okay, what is a shutdown cost, right? So if you have 8 outages in a year and those outages occurred during business hours that your facility would normally be operating, is that a $5,000 cost? Do you have to send employees home? And so really it's what they would consider a, like per instance, resilient value or like resilient adder. I think that's the best and maybe simplest way to approach it. But again, there's no like standard to say an outage cost me $1,000. So that said, it is a bit of a conversational piece with each client to kind of gauge what that entails. Another one that we're looking at saying is just, we would love to see some industry standardization is, if I back up your critical loads 100% and it can run for a longer period of time, well, there should be some base multiplier of whatever you're paying for electricity typically. That allows you to kind of pull away that whole instantaneous or how many intervals you might have an actual outage, and puts it more into the just standard bucket. And what I mean by that is, Ryan, if I can back up 100% of your total critical loads for days, that's worth more money than if I can only back it up for an hour, just plain and simply. Mm-hmm. And so I think when we start bucketizing resiliency, there's different levels of something that only lasts for an hour versus something that's sustainable because it's got other renewable generation or other generation on site. So I think, Justine, you've had some pretty interesting projects where customers have come in and, asking you similar questions. And it is hard to put a value on like, what is that return, especially given that map, we can see some of it's just white, but maybe you want to talk a little bit about what you're hearing on your side as well.
Yeah, as Ryan mentioned, we've been really focused on the resiliency aspect. And honestly, sometimes the discussion about how can this also make money for you or save you money is kind of an afterthought. They are mostly concerned with having that backup power capability. Because to me, the return on investment of, not dying from a carbon monoxide poisoning because you're running your car to charge your phone and stay warm during an outage, that ROI is pretty high, right? Like that's a different calculation that you make. It's an emotional calculation. And so it just doesn't almost even enter into some of our conversations. But on the other side, our battery suppliers are like, you're spending so much money on these battery systems, you should be using them to, on a daily basis, do something for you and knock down those demand charges if you can. And because otherwise you've paid a lot of money for the what ifs, and something you might use depends on your location, obviously, and how many outages you have. But if you really are just planning for those catastrophic events, it's a pretty expensive endeavor. So we're hopeful that you obviously can do both with the right equipment, grid forming inverter and all the right energy management components and controls, that you can sit there and offer both services. And so you can have a financial benefit and not just the backup. But honestly, our focus really has been more resiliency. How are we going to get through this outage and extend our generator runtime, or not even have to have a generator at all? It's different. Their value system is different for each client.
Yeah, and actually it was interesting that you just noted on that generator. One thing that we have seen, in this sort of energy storage plus solar world where, that now can provide some resiliency is also just reducing generator runtime hours, can be another good metric. But again, you're spot on. I mean, the emotional buy is the primary piece. I saw somebody chat through, which is a good one. We see that quite a bit too, is just mitigating future risk, which could be price risk. It could be, resilient, just outage risk. And there is also an emotional aspect of that, of just, I don't want to see my pricing increase, or I don't want to have that outage occur. I think those are really key aspects to understand about the concept of why people focus in on wanting resiliency.
Yeah, I'll speak a little bit to, a couple of the projects that we're working on. One is, through the military department. And so they are, I wouldn't even call it so much an emotional buy, but they're going to be the hub for if and when there is a natural disaster. They have to be ready. They're who people are going to be looking to. And so they have a facility, they're going to have the community looking to them. And so yes, they do have a generator there, but if they can't get fuel to that generator and it's, a 2+ week outage, then what good does that do to have that? And so that's kind of to Justine's point of, it's not necessarily where the savings is an afterthought a little bit, or more of just like a cherry on top. Hey, we can get a little bit of savings too, even better. And so that's been one of the things we're seeing. And so there is a little bit that's out there, and it's becomes an important part of the conversation versus say the business, the grocery store that wants to or has a very definite financial incentive to having the resilience, and so that does become two different ways of calculating that, and one of them is very, very hard to when you can't put an exact dollar on something, and so that's been one of the things that we've been seeing and trying to get people to recognize and find some way of putting a value on. So Quinn, what maybe we won't put resiliency aside completely, but maybe focusing a little bit more on the demand charges. I know, well, one of the questions that comes up is, how do I know if I'm getting charged enough of a demand charge? And I think that's something that this is an NREL chart or a map that we're looking at. And if I remember right, you said you had some kind of guideline principles on talking to people, but it's if you're getting charged a certain amount per kW, your return on investment is probably going to be pretty good. But there's also the calculation of, well, how much does it cost me to begin with? Can you speak to that a little bit?
Absolutely. So I know that it's hard to cast a blank or just a blanket statement out there and have it be accurate in all cases, but it's at least a good guiding post. So when we look at demand charges and just hitting return on investment from purely bill savings, so kind of, yep, we want to, customer is adamant, I have to do something else with my battery. What is that going to bring me? That's really where we focus a lot of our attention and where we've been doing work for the last 7 years. And what that number is about $15 a kilowatt month. So every month your demand charge would be about $15. And ultimately that kind of is that teetering point. Now, does that mean that it has to always be over $15? Does that mean that if it's over $15 that you're always going to save some reasonable amount of money to hit a threshold? And the answer in both of those cases is actually no, because it comes down to a little bit of just what is the cost of installation compared to that. But using some general rules of thumb that I think are good guideposts, we see average installations vary by size, but if we use, some average system size is 100 kilowatt, maybe it's $1,000 a kilowatt hour to install. And in that size bracket, that $15 a kilowatt month for your bill savings turns out to yield something that would be what I would consider reasonable. So a lot of people are looking for at least an 8% IRR in a 10 or 15 year span. We're also seeing the lifespan of batteries push out, because we're even seeing warranties in the 15, 20 year bracket. So a lot of what ends up being that benchmark of being able to say, okay, I look at this graph, it tells me, or this map where the demand charges are over $15, you would think that, okay, none of the other places make sense. And again, I don't want to allude to the fact that that is the only places that'll do it, because there is pieces that are in there. But the nice guidepost that we see is, yeah, use that $15 mark. It'll get you at least a nice benchmark to say, it'll give you a decent return on investment. Obviously, your site conditions, how much resilient load are you putting into it? What are the cost of installations or factors? But we can't say that this will be every scenario, just nice, round figures for us to base it on. The other aspect is I've seen it go all the way down to $10 a kilowatt month, and we're going to talk, and we can talk a little bit later. I'm sure people will ask about, well, what else can I do besides demand charge management? Because ultimately, getting the best ROI on your battery generally means you're doing more than one thing. So just like a customer is saying, hey, I want to do resiliency plus this other piece, both of those technically have value, but in what we call economics, or economic savings of your bill or generating revenue, you're generally doing more than one thing as well, right? You can do demand charge management. In California, you can do demand charge management, time of use arbitrage. In some regions, you can do that and grid services. So I guess in that side, Ryan, as much as we want to say we can use it as a guidepost, it doesn't mean that, while Texas doesn't have a lot of demand charges, that Texas isn't a great storage market. Just turns out for behind the meter, it's not. So sure. I think that's a good place for us to leave that one.
Okay, I'm just going to follow up one quick question. Is that, understanding these are just guidelines that your mileage may vary, right? And so with that $15, I'm just curious, are you saying eliminating that $15 or knocking it down to a lesser value? Or is that even part of that equation?
So it really just comes down to the customer's load profile. And what I mean is not necessarily eliminating the $15. You're eliminating the customer's spikes. And so if a customer has a maximum demand in a month of 100 kilowatts and you install 100 kilowatt storage, that doesn't mean that you're going to be able to wipe out their 100 kilowatts worth of demand. What it does mean, if the customer has, and we're going to get into some of those charts where we have the customer's load profile, when we have that situation where we show that they've got that big spike, and we're just essentially shaving off the peak, we're just reducing that 100 kilowatts to say 80 kilowatts. So there's this aspect of sizing your storage to the right load profile shape, for that customer's facility, is a lot of where, we focus on, optimizing the economic benefit. And this is sometimes where resiliency and best return on investment can go head to head, right? Because if you need a backup load, you might need a pretty big battery, but for doing peak shaving, you might need something relatively small. Which is why when Justine, your people are saying your battery needs to do other things. Honestly, even in demand charge management, you need to start focusing in on how else can I use this battery, grid services and things like that. But to that point, Ryan, you're really just looking at taking that 100 kilowatts, that max demand in the month, and bringing it down, which is maybe one of the more complicated and risky pieces of economic savings, because if you miss one day, the customer's max demand will be still set at 100 kilowatts, right?
Right. Yeah, that was actually the conversation Justine and I were just having about an hour ago. And so trying to make sure that we're getting the everything set up right. So maybe we'll get into that with the controls here in a little bit towards the end. I know we're going to talk about that some. One of the things that we've touched on, and I don't, we haven't explicitly said it, so I think it's worth mentioning, is there's equipment out there, and we've talked about this piece of equipment that can do both grid forming, or do resiliency and do this demand response. And just so everybody out there participating realizes, those are two very distinct and different things, and not every inverter is going to be able to manage or do both of those. So you may have systems that are only demand charge or utility services, maybe it's not, I should say only demand charge is not a right way of doing it, but there's not a resilient aspect to those. They're not grid forming. So Justine, probably you could talk for well more than an hour on just the difficulties and the products that are out there. I'm sure you can too, Quinn. It's we're in a major transition in the industry, and so there's lots of moving parts on that. But I just want to make sure that we were clear on that there are definitely some that can do both, but very often it's a kind of one or the other kind of deal. Okay, and so I think what you were talking about is a great lead into this next slide, into kind of these other things that we wanted to talk about in terms of the modeling pre-install. And I know this is something that Justine and I spent a lot of time looking at. We have you going through, and so I think one of the big questions that maybe a lot of people have, Quinn, is getting this set up right and looking at what the load profiles are. And so I guess one of the questions I would ask for you is, presumably getting the exact load profile from your utility is going to be difficult. I know some utilities are pretty open about it and they get it to you. Others, you get a monthly bill and that's it, and you're not going to get any more detail than that. And so I guess one of the questions is setting up your load profile so that you can understand, what are my demand charges? When are my peaks? When are my demands? What would I be looking at for an outage? How much energy do I really need to do? So I guess, here we have a screenshot from the Energy Toolbase tool. So I was just wondering if you could kind of speak to that a little bit.
Yeah, absolutely. Actually, a couple of really interesting tidbits that you pulled out there is, outside of California, getting your actual interval data to see, what you're using in every hour to compare, when those spikes occur is difficult. Or maybe just not even available because the metering itself is not set up to do that. So you might just I have one electric bill that tells me total kilowatt hours. Maybe it gives me demand value. And that kind of depends a little bit on what rate they are. So one of the things that we've leveraged is the load profiles available from NREL, right? They have sort of published, this is my building type, and you can put in your total kilowatt hours and the tool will actually create what that load profile would look like for that building type. Now, is that something that you can take to the bank and say, this is 100%, what it's going to be? Absolutely not. Is it going to get you close enough because it's based on other buildings that look like yours? Absolutely, because you will see patterns for different types of buildings and their load profiles honestly don't change that much. And then the way that the modeling ends up kind of bringing that in is it knows if your total kilowatt hours is this, it'll actually scale that down based on those intervals. And we will create a 15-minute profile for that customer. Then once you have the load profile, it'll essentially break down, what the savings could be for solar and Solar+Storage. So, that's one thing I think really helps a lot of people when they're going into that pre-installation energy modeling. Frankly, maybe they're just really high level. Does this make sense at this site? They don't want to go through the exercise of getting that interval data or putting a meter out there to see if it matches up. They just need to know if it gets close. And that right there alone is leveraged an absolute ton. Even when you do have the ability to get interval data, people will still use that. We find it to be incredibly useful for people at this stage of the process. And honestly, as much as I say it maybe not taking it to the bank, it's very accurate because those profiles, as we went through a 3-month study of just comparing different facilities that we have in our database, they're surprisingly the same and they scale quite well to see what the actual demand savings could be.
Quinn, can I ask a question?
Absolutely.
So let's say you have a grocery store in Phoenix versus a grocery store up in Seattle. Is there, I guess I'd assume that, if you put in your bill, your kilowatt hour usage, maybe the scaling would adapt to the differences in temperatures or regional variations. But do you guys account for that at all, where this facility is located?
None of the database stuff currently does that.
Okay.
It'll be interesting to see, like there's about, the last I heard, there was like 5,000 or 10,000 new load profiles getting loaded into the NREL database, which I think is going to expand, some of those pieces. So until that kind of comes through, I don't think so. However, what we have, if we have another facility that is close by, our account management team, and we've actually done this very specifically in like other countries like Latin America, where people will come in and say, I have a manufacturing facility. Do you have another manufacturing facility nearby? And chances are we do. So we actually can take that same profile, apply your kilowatt hours if they're known, and we can do the same math with our own reference to load profile. So while it's not as smart to say, okay, you're in this, state versus this one based on the traditional load profiles, chances are we might have one in our database that helps to scale. But we'll see as that new database comes forward. I think it's going to help with exactly what you're kind of alluding to there. Is can it be smarter?
Right.
And I think it will.
Great.
I think the scaling thing is an interesting one because we ran across that as well. And so, looking at the facility today, we can look at what the energy consumption is. We can look at what your demand is and what your energy consumption is. But what if it's, again, I'm going to go back to resiliency. What if there's an outage and all of a sudden your facility looks different than what it does day to day? And so being able to scale that and look at that and be able to say, hey, during this outage, we're expecting 2 times the number of people. And so we as a company, we're seeing, places that are their shelters, their first responder shelters, something like that. So the data that we have right now isn't necessarily going to be perfectly matched up with what their use case is going to be. And so scaling it, I think, is an important thing. And in some cases, I just, you're taking some shots in the dark, I guess. You're just saying this is what we expect it to be, but being able to model that and do the scales is pretty important at what we found.
Yeah, we found it to be incredibly powerful when people want to do increased loads in the future or even decrease loads, I guess, if they're doing energy efficiency, but base it off of their profile. So yeah, it's come in a lot of different uses for the application, but no, it's getting that right in the beginning is really the key to setting up everything else for what your savings, your ROI will be. So the electric bill table, the actual load profile in today's, sort of world of a lot of people doing time of use or having time of use rates plus demand charges or just demand charges alone, Ryan, that's a big aspect that getting it right in the beginning is the cornerstone of everything else.
Great. So yeah, so let's, I guess we can, with that, I think we can move over to Quinn. You had a couple things that you were going to kind of show and talk about as well with respect to the Energy Toolbase.
Yeah, absolutely. You guys have my screen?
Let me see. I see it, but I'm not sure if it went to the right screen. Justine, you're muted.
I see a screen that says Energy Toolbase. Is that what you're?
No, it's
awesome. So
hold on.
What we have here,
I don't think you have. I'm sorry, Quinn. I don't think that they have it. Sorry, it came on my other screen over here. Let me see if I can move it. Sorry, everybody. Here, let me. How come it's not moving for me?
It's on the first slide. Are you wanting to advance slides?
Oh, you're seeing the Energy Toolbase product suite?
Yep.
Oh,
Yep.
I'm sorry. Okay.
awesome.
My bad.
Okay.
Go on.
Sorry about that. All right. So, I think one of the things, if you guys have ever used Energy Toolbase, what we're really most known for is the modeling suite. So a lot of that stuff we call ETV Developer. And this is the pre-installation modeling that people do or use to understand, does my project make sense financially, or at least hit my hurdle rates? There's roughly 1,000 companies that use this to model solar and storage. We essentially have been using this or developing this for a little over 7 years. What we're less known for, because there was a merger about 1.5 years ago, is the controls aspects, the controls and ultimately the monitoring products. So we now have one cohesive suite that goes from the pre-installation, I want to understand if my project makes sense, to the actual control and then the ultimate monitor of my system. So do I think my project makes sense? Pre-installation. I want to make sure that it actually does what I thought it should do, the Acumen control suite. And I want to make sure that after all is said and done, it actually achieved those original results that I thought I was going to get. And that's where we really get into ETV Monitor. So monitoring packages are pretty standardized out there. The one thing that really kind of does stand aside or stand ahead of this is that this will actually show you your real bill savings for what you would have had without solar versus with solar, or vice versa with Solar+Storage. And going on from there, the big part that we focus in on, and I know that we talked a lot about resiliency, that developer software, like projects, a lot of times, at least in the private space, just simply don't go forward unless the customer is completely buying it from an emotional aspect, or it meets some kind of a hurdle rate. So it's basically an investment at that point in time. So thus the focus on getting the return on investment. So that's where you see that price signal that we talked about, Ryan. We got the $15 per kilowatt month. There is a wide time of use differential. So what that means is if I'm buying energy in one time interval versus another in the afternoon, generally, I need those to be roughly 20 cents a kilowatt hour difference for those to pencil out. The other part, and we call this self-consumption, which is when solar might be dumping energy to the grid and it's getting compensated slightly less, is when the export rate is different from retail rate by more than 15 cents. So essentially you're just storing, keeping that solar energy that would normally go out to the grid and export out, you're going to keep that and offset your building load on the road. The other part, of course, that helps boost the incentives is incentives. So SGIP, California, SMART in Massachusetts, and of course the federal ITC. But the big pieces that we can kind of gloss over sometimes is we think that if you hit these things up here, then somehow your project's going to magically pencil out. And the reality is customers' load profile, do they want resiliency? And then is there any grid services or value streams beyond the bill savings that you can take advantage of? So these are some of those wild cards that we alluded to. The 3-month study that really Adam, who I'm in his shoes today, did was ultimately culminated in this masterclass that was hosted by Energy Toolbase, which I know Lucas is going to be so kind as to post a chat link to that webinar. The findings ultimately that we were seeing is that PV and energy storage economics in California are strong. They're probably the strongest out of what we've seen in a lot of the United States, specifically for behind the meter. You can take this and look differently, and we're going to have some questions about what regions make sense for grid services. So we're really focused behind the meter here, but ultimately these are the IRR ranges. They're usually looking at a 20-year term. So to keep that in mind, but between 9 and 21%, pretty big swing in ranges there. But again, it really depends on your load profile, and all the data and backing that up is going to be in that masterclass. So you can kind of see the raw data of what this ends up coming through. The big one that people probably underplay in the storage market, we like to be open book, is ultimately PV contributes the majority of the savings. Energy storage definitely helps bring those demand charges down, but frankly, so does solar, if their demand charges are lining up or their demand values are lining up in those intervals. Also, frankly, the energy storage system is usually significantly smaller than the PV system. Plus just the fact that when you look at your electric bill, a lot of it might actually be coming from your kilowatt hour value, not necessarily your demand value. The other part, and this is something we didn't talk about today, and we can always dive into it, at a later point, but ultimately rate switching is a big thing in a lot of regions. And rate switching just means that I can go to a more solar or storage friendly rate. And what we found is it almost always makes more sense because they're usually giving you higher value for your kilowatt hour or your energy value. The demands are coming down. As a result, you get demand savings just by doing a rate switch. And this is the prime example of that. When you don't do a rate switch, the total cost of your bill, about 78% of it is demand. Well, the savings, I should say. 78% would be from demand, 22% from energy. When you do a rate switch, it literally flips on its head. So most of it comes from the energy savings. And ultimately, the solar has a more reliable way of delivering that energy savings than storage, thus giving you just a bigger benefit to those pieces. And the last one, you'll see this in that webinar, is load profiles. I mean, you can see the difference between a church where they have these huge, crazy spikes and demand savings is just off the charts. And then you have the opposite end of the spectrum of a data center that literally has no change. And even if you really wanted to, you're not going to save them any demand because you just can't bring the profile down at all. So that said, Ryan, this is basically, back to you on those slides, but I think this is just a good, important kind of high level tips that we found in that 3-month study of kind of the economics of solar plus storage.
Yeah,
Quinn,
you said,
oh,
go ahead, Kristy.
a quick statement. Quinn, we have a question from the audience. Someone asked, can you speak to the utility of machine learning and AI in regard to better informing forecasting and optimization of ESS?
Yeah, no, absolutely. So it's actually one thing that I was talking to Ryan and Justine about a bit last night of machine learning is ultimately employed on our controls platform. And the reason that most people are looking at leveraging machine learning models or machine learning in general is you need things to dynamically change. So you want to be able to forecast out and see, what's happening tomorrow. For example, if I forecast tomorrow or if I don't have any forecast, I have no visibility, and I think that I can shave a peak right now, I might be simply just missing the peak that's happening an hour from now or tomorrow morning when I've completely dumped my battery for the afternoon doing time of use arbitrage. So being able to forecast out into the future is ultimately the pathway for stacked revenues and ensuring that you're going to be able to achieve real demand charge reductions. The other aspect of that, of course, is just simply training the model to begin with, which is a big aspect to any deployment. Knowing what happens in the past will help educate the future, but it's not the only thing, because last year's profile could be significantly different to now. So continually having that algorithm updated to provide the best results is really where that machine learning comes in. And the interesting part that we talked to about last night is this concept of adding in resiliency. Okay, so everybody talks about the economic benefit of forecasting. What about being able to forecast having enough energy in my battery to ride through a critical event? Knowing what your future load's going to be, knowing what the battery is doing in each one of those 15-minute intervals over the next 24 hours, and dynamically changing how much you're reserving for those critical events as the likelihood increases. All of that needs to be fed in to really provide what I would consider the best hybrid, resilient plus economic packages that exist out there. And I'm not going to say that I think that all of those things have been resolved for the microgrid or hybrid assets, but everybody's been focused in on largely the great, I can do forecasting to figure out what you're doing tomorrow for your demand charges. But I think that can be leveraged in many, many more ways.
Amazing. And Kathy Nicholson asked, can you please discuss the capabilities of Energy Toolbase with respect to modeling the projected load profile after building and vehicle electrification measures? For example, using heat pumps instead of gas heating and electric vehicles instead of gas vehicles, or load scheduling changes are taken into account. If you could comment on any of that.
I've been asked that question for years, or at least I've been on the other side of the table when I was in that seat because I wanted the same kinds of things. And what I can say is Energy Toolbase is not an energy efficiency measure. So being able to say, hey, I installed heat pumps, what is the reduction for my load, is not built into the UI. However, being able to take that new load profile and building it in is something that can exist. So that whole concept of I can scale my load profile, and it goes beyond just I want to scale my load profile for, percentage wise. Maybe you just want to understand that you're changing your heat pumps out and you know that it's going to reduce your load in certain hours. You can just scale those hours. And that's ultimately where the account management team comes in to kind of help people through those challenges. What we've built essentially, Kristy, is a Swiss Army knife. It's not like it's got every single thing that would work for everybody. It's really focused on solar+storage economics. But because of those advanced functionality, we can really kind of take that and help people understand what the difference in savings would be doing those. But we definitely don't have, energy efficiency measures built into the platform.
Yeah, thank you so much for commenting on that. And Ryan, we'll hand it back to you to continue what you were about to say before we got some questions.
No problem. Well, I was actually going to, I think what you were just talking about there, Quinn, with the leads well into the post installation, but I did actually have a question, something that you were referring to, in terms of the learning aspect of it. One, I guess, is, quite honestly, where does this live? Is this, whose responsibility is that? Is that the energy management system? Is that the battery management system? Kind of what is that interaction? And so I think that's anybody who's been through these projects knows that that's a huge part of everything, is who's controlling what, who's in control. And unfortunately, sometimes there is like standing back and a little bit of a pointing back at each other, trying to figure out who owns what, and ultimately, got to figure all that out. But so that's one of my questions, and I guess the kind of follow up with that is, as soon as I heard you talking about predicting loads, looking at what tomorrow is going to be, or next hour or anything like that, is what's the possibility of incorporating now weather management into that? Can we look at what's tomorrow's forecast? Do I know tomorrow's going to be a super sunny day or a just completely cloudy day, and how will that affect what I want to do with my storage system today?
So I'll answer that one first, because it's I mean, we could probably talk on this one for a whole hour. But basically, there's a couple of things. First, it'll kind of answer both in one. Everything lives at the edge. So we have a computer, a ruggedized computer that lives at the edge that collects the necessary information and then makes decisions and does dispatch for that particular asset locally. Now, one of those things that does come in is forecasted weather data. So we grab, the next 7 days worth of weather data, but we're really looking at the next 48 hours every hour. Some of those bits of data include expected irradiance data, cloud scatter, other things that help us to predict solar output, which generally affects the building load quite substantially, but also the temperature of the that's expected, to see if the building might be hotter that day than other days. So there's multiple different levels of creating what the customer's expected load will be tomorrow. Some of it, of course, is the historical building load. Some of it is the weather data, which is affecting the solar production, which ultimately is going to modify that building load profile shape. And all of that gets woven in to essentially create what we call site net PV, or metered expected load, what the utility company would see. And that ultimately gets fed into our energy storage. Basically, we call it Batman. We have these services that the engineers love to have funny names for, and it just stands for battery manager. And it goes through there and it makes those decisions as it goes through that next time series. Now, as far as that question of like who's in control, it's kind of an interesting one, because out there at the edge, you've got, let's just call it a resilient facility so that we keep it in context. You've got likely some type of isolation device, and I'll call it maybe some load shedding components. So potentially a mechanical breaker with a recloser, or maybe multiples of those built into a piece of switchgear that isolates from the grid and maybe sheds loads. You've got a generator, most likely solar, and then of course your energy storage asset. Typically, all of that sequencing, that rapid sub-second response stuff, needs to be done with a microgrid controller. That needs to be in charge when it's in microgrid mode. Well, the economic aspect where you have the machine learning is typically what we would call an energy management system or EMS function. And you can have an architecture where those two devices live. They can be on the same computer. It's just two different software suites typically. And one needs to be in control. And there's some topologies that we've, undergone to say, okay, in no case will two ever be commanding at the same time. That's a critical piece. The other part is you have the actual PCS, the inverter, and you've got the BMS, as you mentioned. Who's really governing all of those different aspects? And the best control schema will make sure that there is all of those in concert. One thing that I feel that the energy storage world kind of needs to wake up to is this concept of a site controller that's really handling the life safety stuff, because they really rely on like the BMS to kind of do its thing, and they rely on the PCS to do its thing. And that's where you talk about that finger pointing, who's ultimately responsible for making sure the battery's healthy, making sure that it's safe. And I think that a lot of that ends up kind of residing in the EMS world. So again, it kind of depends on your application of what the hardware you're using, what kind of control that they have innately. Do they have a site controller or not? That's a key aspect to ask. Whenever you go into a project is, what hardware? Why do I use this hardware? What kind of control do I need to make sure that it's going to hit my ROI? It'll do the functions that I need. And so, yeah, the who's in charge is a really interesting question.
I have a follow-up. I'm just kind of curious, as we do look at these resiliency projects, if there's any talk of, let's say a storm's coming, something's come from the weather, NOAA, whatever, and it's launched out. People know big storm's coming. Obviously, you want to save as much battery power as you can. Should an event like this happen? Any talk about that being like an automated type of something you can program in? There's an alert, a weather alert that comes in. It's a big storm, and we can, boost that state of charge all the way up and not dump the battery like we were going to at a certain time. Are there discussions about those, or is that just more of a kind of like, yeah, maybe that's a good idea, but we're not doing it now?
We haven't actually brought that topic up. What we have done, on the other hand, is create just like third-party signaling that can come in that we consider an override event. So this concept of overriding the strategy that's running, so this automated, machine learning strategy can be overridden, and already basically just say, okay, we have the ability to essentially roll that in and have a customer override, those features so that they can charge up their battery and have it at full capacity. Mm-hmm. But the concept of, as resiliency kind of comes through in the CNI space, not necessarily where it's been focused a lot of in the residential space, it's just really going to come down to customer demand. Right now, the resiliency, in my opinion, in CNI is just budding right now. They're not adopting at the same speed that they are in the residential space.
Yeah.
Great. I know we have some questions, so and we're getting close to the top of the hour, so I want to make sure that we give ourselves enough time there. So, Kristy, do we have?
Yeah, we have a few questions in the chat. So one question asks, once we have our utility data, how do we verify that the load profile we use is accurately depicted in the modeling software?
So the first thing is just making sure that, and this is where having not just your load profile, but like an actual real electric bill handy is critical. Now, of course, more than 1 month is better because there's seasonal aspects. But, we maintain a little over 75,000 utility rates in the database, making sure that when you put that load profile in, you look at our electric bill table that calculates, this is what your bill should be before solar, that it matches up with what your actual bill is. Now, one thing that people, I think, kind of discount, or when they're going through this verification process, is when my bill doesn't match, there's a few things that can happen. One, your profile is off, and then the other one that's actually more common is rates change on a set interval. Some change every month, some change every 6 months. If your bill was 6 months ago and the rates changed, your same usage might be more expensive now. So first, just sort of comparing your bill this is what the kilowatt hour values are to what we represent, or what any software represents for that matter, is really kind of that process. So you go through that validation phase. If the numbers match up, great, right? Move on. If they don't, there might be some reasons as to why. Has the rate updated, making sure those things are good. Generally speaking, we can get within 1% to 2% of somebody's actual electric bill, given all things equal, that they have the right profile, that the actual bill is on the same, maintained. And we maintain all the historical stuff too. So if you wanted to go back and be like, all right, well, this is a vintage, June of last year, what will my bill have been? So that's the big piece there, Kristy, is just making sure that you can compare your actual electric bill to that electric data.
Yeah, a great segue off of that is the next question, which asks, can you explain 15-minute interval data as it relates to demand charges? How do utilities calculate this value, and how can I see this on my bill? Like, you kind of already started explaining that, but if you want to build off of that.
Yeah, I mean, I think that this one, there's this concept of like my max demand. And when people think about max demand, they think about it like there's 10 light bulbs or 60 watts a piece. So my max demand must be, 600 watts. Well, the reality is, if those 10 light bulbs were only on for half an hour and you're doing it on an hourly interval, or in this case, we're using 15 minutes, so 7.5 minutes. If you only left those 10 light bulbs on for 7.5 minutes, your actual demand would be 300 watts, because they're really looking at, what is the energy usage? And this is like an archaic piece of the network, or the metering infrastructure that exists out in the United States, is they just don't have the capability to record that kind of data and then bill on it. So yes, indeed, a utility company has to supply that instantaneous huge spike that occurs in that 1 second, but they're billing you based on this 15-minute interval. And it's really just the average demand in that 15-minute interval. However, that highest 15p, or that highest 15-minute for the month, is what you get billed on for the month, right? So just understanding first how that 15-minute demand is calculated, and then also noting that whatever the highest is in for the billing period based on the rate, that is your billing amount.
Awesome.
I'm actually gonna do a little follow-up on that. So with you mentioned, the metering and everything, are smart meters, are they putting a change to that?
Not really. The only thing that smart meters are ultimately, capturing that I've seen is, now they can really capture the time of use aspect of billing. So if you go outside of California, not only is it harder to get interval data, but the concept of time of use billing is just non-existent. And if you look at it, a lot of it has to do with the smart metering infrastructure. Is the precursor to unlocking that. So, we've seen that a lot in the Northeast, particularly. They're trying to do smart metering infrastructure up there. And if you look around for time of use rates, they just straight don't exist for the most part, unless you got one of the new smart meters. Yeah. But the idea that you're going to be billed somehow on a 1 minute or 1 second spike, I haven't seen it yet. Not to say it doesn't exist. I'm sure somebody's seen it, but for the different rates we see out there, no, it's not coming through.
Yeah, that's really interesting. Our last question, I think we'll go over, since we are kind of running out of time, is a follow-up from Kathy Nicholson. She added that there's a big push in California to electrify buildings and transportation. So many commercial and residential customers will be making load building and fuel substitution changes. She finds herself looking for energy modeling tools such as Energy Pro to model the expected changes to the customer's load profile before she models her PV plus BESS system. Do you have any suggestions for a good energy modeling tool to use for that?
Unfortunately, that would have to be probably a follow-up for Adam. I personally haven't found one, I know that there's been some high level of interest on our part to find a partner that we can integrate, very much like we did with Helioscope for the PV layout. But ultimately, like who hits all the mark for being able to like put in, all right, I'm changing my bulbs to LED, and this is my new load profile. I just haven't seen it yet, but I'm sure that there's probably something out there. It'd be a great one for Adam to kind of post out in the, Lucas, maybe we can follow up with him and I'll make sure he gets that out to everybody.
Awesome.
So it sounds like that's more than just, and it makes sense to me, but it's more than just changing scales at that point, because I mean, when you're charging the EV, makes a huge difference what that profile looks like, and so it's going to be a, yeah, I see that as being a very complex question trying to answer.
It comes down to just like something that would be full featured, right? I'm sure that there's going to be niche stuff out there that's like, for example, we have some randomizing algorithms that help to add in EV chargers, right? And you can create a new load profile with the EV chargers in it. But having something that can do essentially an energy efficiency audit and then take that and then create the aftermath, that's the maybe we're setting the bar too high. I'm sure that there's some products out there that would get it done for your specific application. But yeah, that's been the thing, is like we haven't necessarily seen that come through. At least I haven't. And that's where maybe just my own, kind of piece falls short, because I focus mostly in on, solar and energy storage stuff.
Sure.
Yeah. Well, thank you for answering all of those questions, Quinn. We appreciate having your expertise. And we're going to have Justine next talk about our Solar+Storage Workshop series.
Thanks, Kristy. Completely different topic. I mean, within the scope, within the realm of energy storage, sure, but certainly not financial analysis of any sort. But we are offering our Solar+Storage workshops, primarily currently based on the 2020 NEC and also the fire codes, which is not shown on this particular screen, but we're just about to launch a ESS fire codes focused on NFPA 855 and getting into those details of why fire codes are important, what are the fire codes that are coming up, how does, say, 2015 change to 2018, change to 2021 for California and New York, and really digging in those installation details when it comes to fire codes. So we've already got one launched when it comes to the NEC and what are those requirements for your Solar+Storage system. But the next one, about to be launched very soon, is specific to fire codes.
Great. Thank you so much, Justine. And for our AMA next month, we are going to be talking about data-driven risk mitigation for solar assets. It'll be a roundtable featuring Retzi and some other folks. So we'll be sending out a post-AMA email with this recording, as well as details for you to sign up for our June AMA. And just to wrap up, thank you so much, Quinn, and the folks at Energy Toolbase. You can connect with them on LinkedIn. You can also learn more about our workshops on our website. And you can connect with Energy Toolbase and sign up for their masterclass, which we'll also be sending out in a link, but you could also see it in our chat on Zoom. Thank you so much for joining this month's AMA. I hope that you gained some really good insights on ROI. And yeah, thank you again for joining.
Yeah, thanks, Quinn. Really appreciate your joining us, and Justine, of course, coming in and giving us your expertise.
All
Thanks
right.
for having us.
Thanks. Bye.
Bye.
Thanks, everyone.